Hello. So I'm just going to do a quick video about how to graph these kind of things. So first of all, these are exponential functions, and they're usually written in the form of y equals a times b to the ex. So y equals a times, I think it said e. I just meant a times b to the x. So these generally look like this. So you have you see x's, and if it's just like that, you have this situation going on. So you have an asymptote, and the asymptote is always going to be a horizontal, so going out this way. So this line right here never touches the x-axis. Now, if you add something else like a -1, that's going to change things. Also, what's going to change things is this minus sign right here. So you can approach these by taking this particular graph and doing transformations, or coming up with a set of points that makes sense. I prefer the set of points just because I think it's quicker and less thinking about what moves around. So I'm gonna make an XY chart right here. I drew arrows out of habit, which I need arrows for that. So you want to plug in points that are going to make things easy. So one of the things in exponential graphs that makes it easy is zero. So if you raise 3 to the 0 power, you get 1. So that's supposed to be 3. So you get -3 times 1 minus 1. So it's going to give you -4. Raising things to the first power also gives you something easy to compute. So -3 times 3 to the first power minus 1. So that's going to be -9 minus 1. That's -10. You could see if you plug in a 2 there, you're going to start getting really big numbers. So you could also try negatives. After a while, you get used to what numbers are going to be good to plug in. So now negative exponents create fractions, which are hard to graph, but or 3 to the -1 just creates a fraction itself. So that's 1/3. Now, -3 times 1/3 is -1. Right, so that you get -2. And beyond that, you're going to get a fraction. Now, your homework problems are pretty much stating that they want integer things. So we're just going to start with that. So that's 0, -4, 1, -10 down here, -1, -2. So you see, it's kind of like it's going up like this, but just going down. So you got this going on, and I'm no good at drawing these lines with the mouse. Um, but then you have this curve going back here towards the asymptote. Now, to determine the asymptote, a lot of times it is this number here, -1. You could also determine that by plugging in a number like way down here, like see what happens with -10. You don't need to get the exact number, but just the idea about what happens. So you get 3 to -10. Without actually computing it, 3 to the -10 is a very small number. So this is like a small number right here. -3 times all this is going to be small. And then you're going to have -1, which is like almost equal to -1, just like a little bit less than that. So that makes sense that it's never going to get above -1. Therefore, -1 is your asymptote. So you could say the asymptote is y equals -1. Okay, so that's your asymptote right there. All right, moving on from this one. Apologize for the delay. Never had this stuff organized. I want to do it all the way yet. Now this one doesn't have an extra term like the other one did, but this have extra stuff in the exponent right here. So we're going to deal with that. So to make an XY chart. The coefficient is positive, so it's going to look like this, like starting off with some kind of asymptote down this way and going up really quickly. So we got to pick reasonable numbers to plug in. Now, reasonable numbers, it seems like 0 or anything near to that, but I want to plug in 0 here because if I do that, I'm taking 3 to the 5th power, which is a very big number. So to get smaller numbers, maybe I'll plug in negative numbers. So if I plug in a -5 into this, then I get 3 times this to the -5 plus 5. That's 0. So I get 3 to 3, 3 times 3 to the 0 power. That's 3 times 1, which is 3. And then I could plug in anything near -5. So let's say -4. See what that does. That 3 times 3 to the -4 plus 5. That's 1. So it's 3 times 3, which is 9. If I start going below that, like -3, then I'm starting to get really big numbers. So maybe I'll go the other way. So instead of going -3, maybe I'll go to -6 and see what that does. That produces a fraction, but it's no big deal because the fraction is going to cancel out. So we get 3 to the negative first power. 3 to the negative first power is just 1/3. So 3 times 1/3, cancel the 3's out, you get 1. All right, so I'm going to plot those points, -6, 1, -4, 9, and -5, 3. So we get these, I can connect those. Again, with the mouse, I'm not good at connecting this stuff, but wobbly. So, and I want to find out whether asymptote is. Now, we don't have an extra term here, say like plus or minus something. So that's going to mean it's going to be 0. So it's going to flatten out like that. And to test this out, you can pick another a number to plug in for x. Let's try -10 again. So we'll do 3 times 3 to the -10 plus 5. And again, you don't actually have to compute these exact numbers. 3 to the -5 is going to produce a fraction, which is going to look like this, like 3 times 1/3 to the 5th. That's a small number. So that's going to be like around 0. So you can assume it's 0. So your asymptote here is going to be y equals 0. That'll be your asymptote again, and it's going to be horizontal. And all these asymptotes for these kind of functions, exponential functions, are going to be horizontal. So we can make that as a rule. So let's say rule, asymptotes for exponential functions are horizontal. So again, exponential functions are in the form y equals a times b to the x. So y equals a number times b to a power. So in this case, what all that would be here, this will be your a value. This will be your b value. Then you get some extra transformation stuff going on here, but it's generally a, b to the x. All right, so moving on to the next thing. Find the equation of the exponential function represented by the table below. In general, whenever you're trying to find a function, you generally use 2 or 3 points. Beyond that, like you don't really see that. It has to deal with the system of equations. Now, systems look like A lot of times you do linear systems of things like intersecting, like you have this line, you want to find out what this point is. This is a little bit different. Um, we're going to start off with the general form for a exponential function, which is y equals a times b to the x. And you always want to use any point that involves zero because those are the easiest to deal with. Now, if you have a zero, this value right here tells you something. But to complete the explanation, let's just try this out. So like, let's say if I plug in a 4 here, 4 for y, I don't know what a is. I don't know what b is, but x is this value 0. So I'm using the point 0, comma 4 to make an equation. So we have b to the 0. Anything to the 0 power is 1. So you're doing this is 4 times 4 equals a times 1. So a equals 4. Important thing to note, all this work here I didn't actually need to do. The fact that this is 0 tells you that 4 is automatically a. So in an exponential equation, a is the starting point. So I'm going to add that here. So an exponential equation, exponential function rather, a is the starting point. Another way we could say that is a is the y-intercept, where it intersects the x-axis, y-axis rather. Now, once you have that, you can plug it into any of these 3 points. So I want to the easiest point, which is the next one involving 1. So it's easier to deal with small numbers. So I'm going to start with y equals a times b to the x again. But this time I'm going to plug in the a value of 4. So y is going to be 12. So we're basing this on 1 comma 12. A will be 4. B we don't know yet. And I'm going to raise b to the first power. Showing extra steps, like you can skip this kind of stuff. Like, so b to the first power is just b. So dividing rules of algebra. So we have b equals 3. So we could take the general form for an exponential, which is y equals a times b to the x. You're going to be using it a lot. And fill in our a and b values. So y equals 4 times 3 to the x. And I'm not sure how you should enter that in, but I would try like something like this, like y equals 4 times, maybe parentheses, 3 to the x. I don't know, all computers are different. Let's just say we picked a different point. Like, let's say we pick this one instead. Let's see how that would work out. So again, you would start with this guy. A, we already found was 4. Right, so this would be like 108 equals 4 times b to the third. So the first thing you do here is divide by 4. 108 divided by 4 is going to be 27. 27 equals b to the third power. And to solve this, you got to take the cube root of each side. And take cube root of 27, cube root of b cubed. We take the cube root of something cubed. It's of course what it originally is, so b. And this is going to be 3. That's the same 3 we see here. All right, so that's it.